Okay, so if we're going to factor x cubed minus 8, do you remember what that factors into, what the formula is for that? Okay, so this is a cubed minus b cubed. Okay, so this is a, or in this case x minus 2, times, remember, x squared plus 2x plus 2 squared, which is 4. That's how that factors. Okay, remember that because you're going to need to factor sum and difference of cubes. Okay? All right. Okay, so look at part B now. So what would the common denominator be for that one on B? 1 over x plus 3 plus 1 over x minus 1 plus 1 over x minus 1 squared.
X minus 1 squared plus x plus 3. Times x plus 3.
Yeah, the common would be x minus 1 squared times x plus 3. Okay. And I'm still working on this stylus and program and stuff, so anyway. All right, so what about part C? Yeah, it'd be the same common denominator, right? X minus 1 squared times x plus 3. Okay, and that's an important difference, okay, as we start doing our partial fraction decomposition here, okay? All right, so if we were going to add the fractions together in part B, what would I have to times each one by? Like this first one, what would I have to multiply that by to get my common denominator? Yeah, by x minus 1 squared, right? What about the middle one? What would I times that one by? X plus 3 times x minus 1, right? And what about the third one? By x plus 3,
I have a
okay?
question about that.
Yeah.
Why don't you use the middle, just the single x minus 1 for your common denominator?
Because this one has two of them. It has x minus 1, x minus 1, so because it has two, I have to account for both of those.
Okay.
So that's why that's part of the common.
Why doesn't it become x minus 1 cubed?
Because I don't need 3. Because in each term, okay, the maximum I have in any one term is 2. I have 2 of them here, and I have 1 of them here. Okay, so because the most I have in any single term is 2, that's the most I need in my common denominator. Okay, makes sense, Kels? Okay, good. Good. Okay, so we're not going to necessarily add those, but as long as you know what we have to multiply it by to get to our common denominator, that's what's important. Okay. Okay, so as you saw at the top, this section is called partial fraction decomposition. So what does the word decompose mean? Yeah, if something decomposes, it breaks down, right? And that's exactly what we're going to do in here, okay? We're going to break down a fraction into its factors. Ugh, boy, I really got to work on this. Okay, now there's several methods for doing this, okay? Some quick shortcuts on easy problems that we'll talk about, and there are some really long, drawn-out methods as well. Okay, the most difficult ones we're not even going to cover in this class, so we don't have to worry about those. That'll be for later on, like when you get to calculus and things like that. You'll be able to handle this. So, okay. All right. Now, one thing though is we can only decompose fractions that are proper. Okay, and you remember what the definition of a proper fraction was? We talked about a couple chapters ago, and it has to do with the degree on the top and the degree on the bottom. Heather. Yeah, if the degree on top is smaller than the degree on the bottom, then we have a proper fraction or proper rational expression, okay? And that's what we're going to do. Okay, so the steps to do this, oh yeah, okay, this one doesn't matter. That's long division, but you don't need to know that on that one. Okay, so we have 5 steps, and I'll go over the steps here. It won't quite make sense, but then as we start doing some problems, we'll refer back to these, and you'll be able to understand a little more clearly what we want out of this, okay? All right, so the first thing we need to do is factor the denominator completely, okay? So we will get possibly repeated factors. Oh, and this isn't big enough. Okay, so we'll get, sometimes we'll get repeated factors, sometimes, and a lot of those will be binomials. In fact, most of them will be binomial factors, okay? And sometimes we'll get what are called irreducible quadratics. All right, so again, so the first step is to factor the denominator completely. Now we want to break the fraction into parts, the parts it may have come from based on the factors in the denominator. Okay, so one part for each factor in the denominator and one part for each repeated factor if necessary. So we're going to basically take our denominator, our factor denominator, and we're going to split it up, okay, into however many different parts we need to, and I'll show you how many different parts we need to do that, okay, as we go. Okay, then we need to place the coefficients, okay, and they're undetermined because we're not sure what they are yet. That's what we're finding. Okay, in the numerator of each of the parts. And remember, the degree of the numerator is always 1 degree less than the degree in the denominator. And that's an important one, okay? Degree in the numerator is always 1 less than the degree in the denominator, okay? Now we need to clear the fractions in the equations and then use the appropriate method to solve the undetermined coefficients. Okay, so these are called, so there's several different names and they all mean basically the same thing. And there's a couple different methods that I'm going to show you today. And again, you choose which one is easiest of the two methods, okay? If there's a certain type of fraction where one method's a little easier, a certain type where another's a little easier, but they'll both work for all types of these fractions, okay? So we have one, and this came from Itinerus, from one of the teachers, what she calls her sweet numbers. The other ones, we're going to use systems of equations, which we know. And then this other one, all over Heaviside, it's called the cover-up method. But it's pretty similar. It's kind of a combination of the other two, so we won't necessarily cover that one specifically today. But we'll do the sweet numbers and the systems. Okay? All right, and then we rewrite the original fraction as the sum of its parts. Okay, so what does all that mean? All right, so we're going to start with something easy now. So what's our first step? Factor the denominator, right? So what does this denominator factor into? X plus 1, x minus 1. Okay. Now, and I didn't write that very well. Okay. So now we're going to place. So what was the second step? What did the second step say? Okay, so that's what I'm doing here. So I'm breaking this into parts, and I'm going to put a plus sign in between them. Okay, so what we're doing is take that denominator and we're splitting it up. Normally we take different denominators and we put them together, right? Well, in this section we're just putting that process in reverse. We're taking denominators together and we're going to split them up. Okay? All right, so we just split that into two separate parts. Now what's the third step? For the undetermined coefficients, right? So we're going to call this one capital A, and I apologize for not writing this so up there so high. Let me see if I can fix that. There. I'm going to call this one B. Okay, capital B. So there are our undetermined coefficients. Okay. So now, what's our next step? Yeah, I want to clear the fractions. So now we want to take this equation here and we want to solve it. So we want to get rid of all of our denominators. Okay? So that means we're going to multiply everything by our common denominator, which is x squared minus 1, or x minus 1, x plus 1. Okay? So I times this by x minus 1, x plus 1. I times this by, I'm sorry you can't read this, gosh, x minus 1, x plus 1, and times this by x minus 1, x plus 1. Okay? So now over here on the left, everything, those all cancel, and I'm left with 3x cubed plus x squared plus 5. Again, over here on the right side, the first one, the x plus 1's cancel, so I get a times x minus 1. And over here, my x minus 1's cancel, so I get b times x plus 1. Okay. Now, what our goal is to solve for a and b here. Okay, but we can't do it. We're not going to do it simultaneously. Let's do it one at a time. So we're going to do what right now it's called the sweet numbers method. Okay, so if I want to solve for a here, I've got to eliminate b. And what's the best way to eliminate b right there? By making x what? Not x 0. I want to make that x plus 1 0, right? So I want x to be negative 1, right? So we're just gonna say, I'm gonna say here, let x equal -1. And then everywhere that I see an x, okay, like here and here and then here and here, everywhere I see those x's, I'm going to plug -1 in its place. Okay? All right, so on the first one, so I get 3x cubed. So if x is -1, what's 3 times -1 cubed? That's going to be -3, right? And then I get plus -1 squared is 1 plus 5 equals. Now, what happens here? When a is -1, what do I get there? -2a, correct? Now, what do I get over here? That goes away. Okay? So now I get 5 plus 1 is 6. 6 minus 3 is...
Why is it plus 1?
Because -1 times -1 is...
Oh, it's x squared.
Yeah, it's x squared. Yeah, look up here. Okay, so over here I get 3. And here I get -2a. So if I divide that out now, I get a is -3/2. Okay? All right, now we're going to find b. Okay? So to find b, I need to get rid of a. So what am I going to let x equal to get rid of a now? I'm going to let x equal 1, right? So if x equals 1 over here, so now we get 3 plus 1 plus 5 equals, the a part goes away, we know that one, and then I get 2b. Everybody following so far?
You don't just want to plug in A?
No, especially because a is a fraction, that's just going to get ugly. So let's just, when we can easily eliminate it, that's the best method to do. Just get rid of it, all right? Okay, so now let's see, 5, so that's what, 9? So we get 9 equals 2b, and b equals 9/2. And we are done now, except for what does the last step say? Rewrite the original, okay? So this is going to, so our answer is going to be this. So we have a, which is -3/2, over x, what was it, x plus 1? Plus b, which is 9/2, over x minus 1. And that is your final answer right there. Don't do anything else with it. You don't have to simplify those fractions or anything. You leave it just like that. So now we've broken that original fraction down into certain parts. Okay? So if I were to get a common denominator and eliminate the 2's and all that stuff, eventually I would wind up with 3x cubed plus x squared plus 5 over x squared minus 1. And that's what we're doing. We're just putting this whole process in reverse. Okay?
So how far do you go to simplify it?
That's it. You're done right there. That's all I have to do. Once you find a and b, you're done. Okay? All right. Let's do another one now. All right. So, again, so let's go here. So first step, we factor the denominator. So what does x squared minus 5x plus 6 factor into? X minus 2, x minus 3, correct? So that's what we're going to break it down into. X minus 2, put an a over that, plus b over x minus 3. Okay? All right, so now we've factored the denominator, we've separated it into two different fractions. Now we need to clear our fractions. So we're going to times everything by, which is x minus 2, x minus 3. So we times, so over here on the left, okay, it's the denominator is going to wipe out, so I get x plus 1. What's going to happen on the right? I get a times x minus 3 plus b times x minus 2. Good. Okay, now again, so now let's start using our sweet numbers. Let's do that method, and then I'm going to show you how to use systems of equations to solve it as well. Okay? All right, so our sweet numbers. So let's get rid of b. So what are we going to let x equal? X is going to equal 2. Good. So on the left, I get 2 plus 1 is 3. On the right, I get 2 minus 3 is -1, so I get -a plus, what happens with b? It goes away. That's what we wanted to do, right? So if 3 equals negative a, then a equals negative 3. Good, we're done with that one. Okay? Now we want to solve for b, so we got to get rid of a. So now we're going to let x equal what?
3.
X equal 3. Good, look at you guys.
This is so simple. I'm gonna go math Excel.
Oh, it's going to get harder, dear. Even before you get to math Excel.
Easy.
Yeah, yeah. Okay, anyway. But once you get the method down, it's not too bad. All right, so we get 3 plus 1 is 4. Now, a goes away, and b, and I get what times b? Let's see, x is 3, so 3 minus 2 is 1, so b is 4. There we go. So now our partial fraction decomposition looks like this. Negative 3 over x minus 2 plus 4 over x minus 3, and that's your final answer. Okay. All right. So now that's how you do it with sweet numbers. Now let's show you systems of equations. All right. So with systems, we get to the same. We start with the same steps until we get to this point right here. Okay. Now, with systems, what we're going to do, now we're going to distribute our A and our B. And then we're going to combine like terms. Okay? So we're going to get x plus 1 equals ax minus 3a. And then we're going to go plus bx minus 2b. So, yeah, that's right. Okay? So do you see what I've done there? I've just distributed my A. And I've distributed my B. Okay, Larissa, so I took the A and I times it here and here. And then I took my B and I multiplied it there and there. I just distributed those two variables. Okay, that's all I've done. All right, now, to set up systems, we need to account for our exponent, for each exponent as we go. Okay, now the nice thing here is our biggest exponent is is 1, right? I don't have any x squareds or x cubed or anything like that. I've got x's and I've got constants. So when I have an x, now what we're going to do is we're going to write everything down like a system of equations. Okay, like a matrix, but without the x's. Okay, so on the left side, okay, I'm going to write down the coefficient, which is 1.
Question.
Mm-hmm.
Could you do AX, so should it be BX?
Oh, yes, it should, Larissa. Good call. That is bx. Yes, you're exactly right. Thank you. Okay. All right. So now again, so we're writing down all our terms that have an x in them, an x to the first power, but without the x's. So I get 1 over here equals a plus b. There's 1. Okay. Now we're going to write our constants down, or just our numbers.
Why did
Okay.
you write down? Oh, okay, I got you.
Because they don't have an x with them.
Yeah.
So I wrote down each individual term that had an x with it, but without the x, okay? Now we're going to do the same thing for our numbers. So we have, again, on the left side, we have 1 equals, now I have minus 3a minus 2b. Now notice what I have here. I have a nice little system of equations, and we can solve this using either substitution, or we can solve it using row operations, or we can do matrices with row operations, or we can do elimination. Okay?
Can you set them equal to each other?
Yeah, that one we could because they're both equal to 1. That rarely happens, mind you, but we could do that. But with this one,
Why
seriously,
are they equal to 1?
because this is 1x right here, and then this one right here.
Give it all that to you.
Okay? So now for me, personally, I would do elimination here. I would times this equation by 2 and get rid of b. So we get, and I'll write my answer down below here. So I get 2 equals 2a plus 2b. We'll do a bunch more of these. So if you don't get it all on this one, don't worry about it. You can see we got 3 pages. We're going to do a lot of this. So here we get 3 equals negative a, and so a is 3. Now, the nice part about the systems, okay, is that now we can just take A and we can plug it back into one of those equations and get B, instead of having to do that's kind of where sweet numbers lags a little, okay, because with the sweet number method, okay, once I get A, that's great, now I have to let X equal something else and plug it all in and find B. But now here, since I know A is -3, okay, I can just take -3 and I can plug it in, let's say right here, and I can solve for B. So I get 2 equals,
Can you just go higher up in the ball?
oh yeah, that's even easier, dude, good call. See, that's why I keep you guys around. Yeah, so we can plug A in right here, -3, so we add 3 to both sides and we get B is 4. That's a B, believe it or not. Oh. Ooh, oh, no, that's bad. How do I undo that? Well, that sucked.
There's that arrow.
Okay, now that we completely wiped out all that other stuff somehow, I don't know what I did, but I apologize. Okay, so now we've got our 2 methods, right? So let's get going. Okay, let's do a lot of practice so we can really understand this. I'll at least post this part so you can see the practice that we're doing. Okay, so again, first step. Factor that denominator. So what does x squared minus x minus 12 factor into? Okay. So now we separate them. Okay, times everything by x minus 4, x plus 3. So on the left we get x. On the right we get a times x plus 3 plus b times x minus 4. Okay. Now, let's do the systems one again on this one so you can see it again. All right. So we're going to distribute a and b. So I get x equals ax plus 3a plus bx minus 4b. Okay, so now we go our x to the first here. So we get 1 equals a plus b. Now we're going to go just our numbers or our constants. So on the left side I don't have 1, so that's 0 equals 3a minus 4b. Okay. Because on the left side it's like x plus 0, if you will, because there's no constant number. There's no number without an x. Okay? So, now again, substitution or elimination. What do I do to solve this? Elimination. Okay, so let's times the top equation by, let's say 4. Good call. So we get 4 equals 4a minus 4b. And then we get 4 equals 7a. And a is, oh, that's plus. Yeah, sorry, you're right. Yeah, so a is 4 over 7. Now here's where systems can suck, okay? Because now I got to plug that, but this one's not too bad. So I know a is 4 over 7. Okay, now I got to plug that in. We'll plug it in right here. So I have 1 equals 4 over 7 plus b. What's 1 minus 4 over 7? 3 over 7, right? So we get b equals 3 over 7, and we're done. So now our final thing, again, our final step, we have to write this, so we get 4 over 7 over x minus 4 plus 3 over 7 times x plus 3. And that's your final answer right there. Okay? And that's using systems. Okay, not too bad? All right.
Does it get harder than that?
Okay, so now here we got to factor our denominator again. So we take our GCF out, which is x, and then what's left? X squared minus 2x plus 1. Now what does that factor into? Okay, what does this factor into? Yeah, x minus 1 squared, correct? Okay, so now here's how this one needs to look. Okay, so now we're going to have more than just 2. So we're going to break it down into a over x plus b over x plus 1, x minus 1, sorry, plus c over x minus 1 squared. Okay? Again, because we have to account for all the possibilities of that GCF. So that greatest common factor was x and x times x minus 1 squared. Correct? Okay. So could x minus 1 be a factor of that?
Yeah.
Sure. Could x minus 1 squared be a factor of that? Yeah. Can x be a factor of that? Yeah. So we have to account for all of them.
Why is it x minus 1 squared? If you add all those together, wouldn't it be x to the 4th?
No, we're not adding. No, we're not adding stuff together. We're just okay because this factored into x minus 1 times x minus 1, right?
Yeah.
So that's x minus 1 squared.
Yes, then why would you have another one?
You don't have to add it all. You don't have to look for it.
I don't. This one isn't. This one, the middle one isn't x minus 1 squared. But if I have x minus 1 squared, one of the factors of that could be x minus 1.
If you're gonna get a common denominator, you don't have to do x minus 1 for both times. You just
Right.
multiply the middle one by x minus 1 times x, and then the other one by x minus 1.
So what? So Matt, let me ask you this. What's the common denominator of this, this, and this? What's my common denominator? X times x minus 1 squared, correct?
Yeah.
Okay, so that's why I have to write, undo that, please don't screw it up. No, it's not doing it. Okay, never mind. That's why I have to write all 3 of them though, okay? Because my common denominator is x times x minus 1 squared. Well, x minus 1 is a factor of that, so I have to include it. And that's why I can't just write a over x plus b over x minus 1 squared. Because then I'm missing another possibility, which is just x minus 1. Okay? All right. We okay, bud?
Yeah.
All right, good. Good question. All right, so now I got to times everything by my common denominator. Okay? So, what's left? So on the left, we have just x plus 2. On the right, we have a times x minus 1 squared. See, this is why I asked you this on that starter question. Plus b times x times x minus 1. Good. Plus c times x. Okay. All right. So, do you want to do elimination or systems or sweet numbers? Sweet numbers? Okay, let's do sweet numbers. Okay. So, let's solve for a. So, we got to get rid of b and c. So, what's x going to be here if I got to get rid of b and c?
0, 0.
0, right? So we're going to let x equal 0. So on the left side, I get 0 plus 2 is 2. On a, I get 0 minus 1 is negative 1 squared is 1. And now what happens to b? Goes away. What happens to c? Goes away. We're done with that one. We got a equals 1. Okay? 2. That's what I said. Ace. Okay? All right, so now let's solve for c. So now I got to get rid of a and b. So we're going to let x equal 1, correct? Okay, so we get 1 plus 2 is 3 equals a goes away, b goes away, and I get c times 1 is c. So c is 3, okay? Now, we've got to solve for b, so we've got to eliminate a and c. Now, here's where we have a bit of a problem, right? Because there's not a number that I can plug in that's going to eliminate a and c, but keep b around, okay? So now what we have to do, we have to plug a and c in, okay, and then pick any number we want for x, and then we just solve for b, okay? So yeah, it's still not too bad. So let's go, okay, so what number should we let x equal? And let's be smart about it. It can't be 0 and 1. It's got to be something else. I'm probably thinking 2 would probably be our easiest,
I
right?
can if you want.
Because we already did one right here, and one would eliminate A and B, and we can't eliminate B now because we've got to find B.
So you can't do 0 because we would eliminate that one.
Exactly, because it would eliminate B again. We can't eliminate B, so we're gonna, but 2 is probably a pretty easy one, right? So we're gonna let x equal 2. And then we're gonna, but now we have to plug in A and C as well. So on the left, I get 2 plus 2 is 4, equals. Now I get, A is 2, so I'm gonna go 2 times 2 minus 1, which is just 2, that's pretty easy, plus B, which we don't know, times 2 times 1, so B times 2, we'll just make that 2B, plus C, which is 3, times X, which is 2, so 3 times 2 is 6. Okay. Now we solve for B. So we're going to minus the 2 and the 6, so we're just going to minus 8 from both sides. So we get negative 4 equals 2B, and B is negative 2.
This one we had x equal 2, right?
Yes. Okay, so now we rewrite it again, so we
Why
get,
are you minusing 8?
because I had a 2 here and a 6 here. All right, now we're done. So we get 2 over x plus B, which was negative 2, and negative 2 over x minus 1. Now leave that negative up there like that, so do plus negative 2 over blah, 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 okay? Don't mess with signs or anything like that, okay? And then plus 3, which is C, over x minus 1 squared. So you can see, Maddie, that's why we got to have that middle term there, okay? Otherwise, we'd lose that one, and that would be bad, okay? Okay, now, the nice thing with 14 is already factored for us, right? So we're ready to roll here. So we got set equal to A over x plus 2 plus B over x minus 1. Okay, so now we times everything, wipe it out, so we get 3x equals A times x minus 1 plus B times x plus 2. Okay, sweet numbers is probably the easiest one here because we can eliminate both of them pretty quick. Okay, so we're going to let x equal 1. Okay, so we're going to get rid of A. So 3 times 1 is 3. A goes away. B is, okay, so 1 plus 2 is 3, so we get 3B, and B is 1. Okay, now we're going to let x equal negative 2, good. So 3 times negative 2 is negative 6, equals. Negative 2 minus 1 is negative 3, and then B goes away, it's what we want, and we get A is positive 2. Wow, we're done. So we get 2 over x plus 2 equals, what was B? 1 over x minus 1. No, not equals. That's plus. Yeah, that's plus.
Shouldn't it be opposite, actually?
Yeah, that one was nice.
No, that's right.
And all the numbers?
No, we got A is 2 and B is 1.
Oh, no, that's.
Yeah, we're okay.
I was thinking.
All right, now, 16 here is a little different. Why? Because look at x squared plus 4. Can I factor that? Can I factor x squared plus 4? I can't, can I? So this is what's called an irreducible quadratic. Now remember our rules. When we break this up, the power on top has to be 1 less than the power on the bottom. So I got to have an x to the first up top. So let me show you what this is going to look like now. Okay? Oops. Okay, time out. Okay, so now here's how we break this one down. Okay, so our denominator is already factored, correct? We can't factor that denominator anymore. So,
15 you just put undefined, or is it unreduced, irreducible,
which one?
or the one you just wasn't?
This is the same one I'm doing,
Oh.
right? So no, it's not undefined, but here's how I have to handle it. Okay, so we get A over x plus 1. That's pretty simple. But now, since my power on the bottom, my degree on the bottom is 2, I have to have a degree of 1 on the top. So I do this. I make it look like this. I go bx plus c all over x squared plus 4.
So is
Okay.
that like an equation we're supposed to follow?
Uh-huh. So the power on top is always 1 less than the power on the bottom. So since I can't factor x squared plus 4, I have to leave it as it is, right? So because that's an x squared, I have to have an x up top, okay? To make it
Even though
a
it
proper.
was on C on the last one is.
Right, yeah, the A, B, and C don't matter. I could make this X, Y, and Z, or you know, S, T, and U, or
Well, I'm
whatever.
just saying it still has a square, so that means there's 2x on the bottom.
Right, but I was able to factor that one. So that's why I don't have an X up top. Now, and so if you can factor it all the way down, and then it's easier. The more you factor it, the easier it becomes, okay? All right, so,
Where the x goes? Could
what's-
it be b plus cx?
no, it's gotta be BX plus C. Well, yeah, but just for consistency's sake, yeah, let's keep it like this.
I'll never get it wrong because it was like supposed to be cx.
Right. Or we'll do one where we get it like an AX plus B and then a CX plus D type thing. I'll show you that in a minute, okay? Oh, it's not that hard. It's really not, okay? Because the steps are all the same. So now we times everything by our denominator. So we get 1 equals A times what? X squared plus 4 plus BX plus C times X plus 1. Okay, now here is where I really like systems, okay? Now we can still do sweet numbers, but the problem is, okay, we can eliminate B, well, B and C by making X negative 1, but that's about all we can do is the problem, right? Because we can't eliminate A, because there's nothing I can plug in for that to eliminate A. I can eliminate B by making X 0, but then I've still got lots of stuff going on. So let me show you systems here and see what you think, okay? All right. So to do systems, I've got to multiply everything out here. So I got to distribute my A and I got to FOIL together BX plus C times X plus 1, okay? So now to put those together then I get 1 equals AX squared plus 4A. And then to FOIL these together I get BX squared plus BX plus CX plus C. Now that looks really complicated, yeah? Okay, it's really not, okay? Now remember, we're doing systems here, and we start with our biggest power. So what's our biggest power we have? X squared. So there's no X squared, so we're going to go to X squared. That's our first one. There's no X squared on the left side, so that's a 0. Now write down everything with an X squared in it without the X squared. So what have I got? A plus B. And that's it, right? Okay, so now we go to X. Okay, again, there's not an X on the left side, so that's a 0. Write down everything that has an X. So we just have B plus C. And now we do our numbers, or our constants, right? So now on the left side, now we have 1. And what do we have on the right side? 4A plus C. Okay, now we're ready to rock and roll. Okay, so if A plus B equals 0, what can I do with that? I can say A equals what? Negative B, right? Okay.
Is that a 2? What is that Jim ratio there on the left? Under the x.
Oh, that's just a number, not numbers. Hashtag for you guys. Like what it really means, it's a number symbol. That means a number. So constants.
So A and C can equal each other.
Okay, now, okay, everybody here, Jacob. Jacob, say that loud again.
A and C.
A and C are going to equal each other, right?
A and C are?
Correct. That's one thing. Because if A is negative B, and if I simplify that one, I get C is equal to negative B as well. So A and C are equal to each other.
But you could do B is equal to negative A.
Yes, I could. And I could also do C is equal to negative B, and or B is equal to negative C, and then negative A is negative C. Yeah, so it all comes full circle, right? So now if A and C are equal, then I can replace this with an A, right? So then I get 1 equals 4A plus A, which is 5A. So A is 1/5. Well, if A is 1/5, guess what C is? And guess what B is? B is negative 1/5. We're done, people. That's why we like systems. Okay, so let's go through this again. We kind of talked our way through it, but we didn't. So we got A is negative B in the top equation. We got C is negative B in the middle equation. So we have A equals C. Correct? We all okay with that? Now, I took C, right, excuse me, I took A and I plugged it in right there. So then I get 4A plus A is 5A. 1 equals 5A, and so A is 1 over 5. Okay?
You can also do that.
Larissa, how about it? We good? You got A is 1 over 5?
Yeah.
Okay, now, A and C are equal. So if A is 1 over 5, then C is 1 over 5. Okay? Now A is equal to negative B. So if A is 1 over 5, then B is negative 1 over 5. And we're done.
Are there gonna be lots of those
There'll be a decent amount.
that equal each other?
So let's rewrite this. So we get 1 over 5th, or 1 over 5th, 1/5 over x plus 1 plus negative 1/5 x plus 1/5 over x squared minus 4, plus 4. There's my final answer right there. Okay.
These are kind of the same.
Okay, so now this one, all right, it's already factored. So let's write out our decomposition. So we have A over what? What is x plus 2 plus, now do I have to do a bx plus c here? I don't, because that I can write as x plus 1, x plus 1. Right? I can break that down. So I don't have to have a bx plus c or cx plus d. So this is just b over x plus 1 plus c over x plus 1 squared. Good. Okay. So now we times by our common denominator. So on the left we get x minus 3 equals a times x plus 1 squared plus b times x plus 2 x plus 1 plus c times x plus 2. Okay. Sweet numbers, probably best with this one. Okay. So let's solve for A. So we're going to let x equal negative 2. Okay, so on the left I get negative 5.
Wait, why?
Oh, I'm sorry. Yeah, negative 2 because I want to get rid of B and C. Right? I'm solving for A. I'm solving for A. I'm not eliminating, I'm solving for A. So I want to get rid of B and C. So to get rid of B and C, I'm going to let x equal negative 2. So we get negative 5 equals, let's see, negative 2, that's negative 1 squared is just, there, we're done. That's A. A is negative 5. Because we know B and C are going away, right? Cool. So we already got A. All right, now let's solve for C. So now we're going to let x equal negative 1. Okay, so then it gives me negative 4 equals, A goes away, B goes away, negative 1 plus 2 is 1, so there's C. Okay, now, to solve for B, we have to, plug in A and C and let x equal something. Okay? Yeah, I would probably say 0. If you ever use 0, always use 0 because it's easy. Right? So let's let x equal 0, and then again, we got to plug in A and C here. So we get negative 3 equals, A was negative 5, so it's negative 5 times 0 plus 1, so it's just negative 5, plus B times 2 times 1, or 2B, plus C times, plus 2C, and C was negative 4. Okay, so now we get negative 3 equals negative 5 plus 2B minus 8. Is that right?
Yes. Yeah.
Everybody check my math, please. I'm not confident that's right.
That's right.
Is that right? Okay. I'm going to trust you guys. If you screw me up, ooh. Okay, so what am I going to add to both sides now? Yeah, good. Add 13 to both sides. Oh, yeah, this works out clean. Never mind. So 10 equals 2b, and b is 5. There we go.
So if we did it the other way, would we have found out that,
You probably get a equals negative b. If you did systems. Yeah, or b is negative a. You got one of those two, exactly. Exactly. So we get negative 5 over x plus 2 plus 5 over x plus 1 plus negative 4 over x plus 1 squared. All right, this last problem. All right, this is as hard as it's going to get right here. And this actually isn't too bad. Okay, now, so how do I break this up? So can I factor x squared plus 4? I can't, okay? But I've got x squared plus 4 squared. So we break this up into two separate ones. So we're going to have ax plus b over x squared plus 4 plus cx plus d over x squared plus 4 squared. Okay. All right, so we times everything by our denominator. We all got that down, right? So we get x cubed plus x squared equals ax plus b times x squared plus 4 plus cx plus d times times 1, right? That is our common denominator. That's the nice thing there. Okay? Now, again, for this one, sweet numbers, a little iffy, right? So let's FOIL that out and let's do systems here. Okay? So we're going to get x squared plus, or x cubed plus x squared equals, FOIL these out now, so we get ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. Whew!
Are there things we want to do on the test?
Of course.
You keep asking if there's gonna be.
I'd count on it
Hey, how come you never multiplied cx plus d times x squared plus 4?
because I didn't need to. Because cx plus d, this was my whole denominator. That was my common denominator. So when I times by it, I wiped it all out, right? So that actually makes this pretty easy. Okay? All right, so what's our biggest power? Hang with me, Larissa. Come on. What's my biggest power? X cubed, right? So let's start with that one. So on the left side, I get a 1 equals. What have I got on the right side? I've got a. Do I have any other x cubes? I don't. I'm done. I already know a equals 1, just like that.
Oh, yeah.
Okay? All right, so now we go to x squared. So again, on the left side, I have 1 equals. What x squareds do I have? Just bx squared, that's it? Freak. Seriously, can I give you anything hard here? I'm not thinking so. Okay, now we go to x to the first. On the left side, ain't nothing. Okay, now on the right side, I have 4a plus c. Correct. Well, what is a? A is 1, so what does that make c then here? C is negative 4. Are you kidding me?
Do you have to keep going? Oh, wait.
Well, yeah, we got to get D. So let's get our hashtags, our numbers, our constants. Freak. So on the left side, we got nothing. And what do we have on the right side? We have 4b plus D. And what's B? 1. So what is D? We're done, people. So we get 1x, or x plus 1 over x squared plus 4 plus negative 4x minus 4 over x squared plus 4 squared. Partial fraction decomposition. Boom!